Evaluate integral c e power z by z into z minus 1 whole cube dz, where c is a curve mod z equal to 1 by 2. So this integral we can evaluate in the two ways. One is a Cauchy's residue theorem and Cauchy integral formula. We will see both of them. So now given integral c e power z by z into z minus 1 whole cube dz. So what is this mod z equal to 1 by 2 means? Is a circle, that means we can write this as a mod z minus 0 equal to 1 by 2. That means center 0, radius 1. So you roughly draw the diagram. Center 0, radius 1 by 2. This is 0. So this is radius 1 by 2, center 0. So now first applying for this Cauchy residue theorem. So to apply Cauchy residue theorem, first you need to find the poles. First step, poles. To find poles, make denominator equal to 0. So what is it? Z into z minus 1 whole cube equal to 0. So z equal to 0 comma z equal to 1. So you got two poles. Poles are 0 comma 1. So now when you apply Cauchy residue theorem, you have to see which pole is inside. Only inside poles you have to consider. So when you take 0, 0 is inside the circle, 1 means it may be here. So this is 1. So 0 pole is inside the circle. This your circle, mod z equal to 1 by 2. So 0 pole is inside the circle, 1 is outside of the circle. So you need to consider only inside the circle. So the pole 0 is inside the circle. At this point we will find the residue. Okay, residue of f of z at pole z equal to 0. So now residue of f of z at z equal to 0. Z equal to 0. See, z equal to 0, how many times repeated? Z power 1. That means z equal to 0 is pole of order 1. Okay, pole of order 1. So now formula, residue of f of z at z equal to a is equal to limit z tends to a, z minus a into f of z. So this is a formula. This is a formula when pole of order 1. Pole of order 1. Okay. So now here pole is z equal to 0. That means this is a equal to 0. So residue of f of z at z equal to 0 is equal to limit z tends to 0, z minus 0 into your f of z. What is f of z? E power z by z into z minus 1 whole cube. This total, what is f of z means here? 1 minute. What is f of z means? This is your f of z. F of z equal to, this total is f of z. F of z equal to e power z by z into z minus 1 whole cube. So now, so f of z you have to substitute this. So z minus a means 0, z minus 0 into f of z, e power z by z into z minus 1 whole cube. So now residue of f of z at z equal to 0, limit z tends to 0 z into e power z by z into z minus 1 whole cube. This one z get cancelled. So therefore this equal to substitute 0 e power 0 by 0 minus 1 whole cube, that is 1 by minus 1 minus 1. So now residue of f of z at z equal to 0 is a minus 1. So only one pole is inside. When you take the circle, z equal to 0, only one pole is inside, so we find residue at that point. How many poles are inside? At that many points you have to find the residue. So here only one pole inside, we find residue to one pole only. So that is z equal to 0. So now by Cauchy residue theorem, by Cauchy's residue theorem, integral C f of z dz equal to 2 pi I into sum of residues of f of z at poles inside C. Okay, so only one pole is inside, therefore 2 pi I into sum of residues poles inside C. Only one pole z equal to 0 inside, its residue is a minus 1. So this value will be minus 1 minus 2 pi I. This is a integral C. What is f of z? F of z means e power z by z into z minus 1 whole cube. So e power z by z into z minus 1 whole cube dz. So you got its value. So this we applied Cauchy residue theorem. Okay, so now another way, this problem we can do in another way also in the next page. Another way. So another way what you are doing means same problem, Cauchy integral formula. Cauchy's integral formula. Same problem, you can write over R. So now again problem. This is integral C e power z by z into z minus 1 whole cube dz. Integral C e power z by z into z minus 1 whole cube dz. C is a circle, mod z equal to 1 by 2. So now in this what you have to do means again you draw the circle. So center 0, radius 1 by 2. Center 0, radius 1 by 2. So now which are the poles? Z equal to 0 is a pole, Z equal to 1. This 1 is here outside. So now remember we are applying Cauchy's integral formula. How to apply means, in a Cauchy integral formula, which pole is outside? Which pole is outside? Z equal to 1. This z equal to 1 pole is outside, so corresponding factor take into numerator. Remember this, you have the two poles 0 comma 1. Which pole is outside of the circle? Therefore here 1 is outside of the circle, corresponding factor take into numerator. That is a key point. So integral C e power z by, so z minus 1 whole cube by z into dz. So 1 is outside, so 1 corresponded factor z minus 1 whole cube, that you take into numerator. So therefore this will be integral C. So now what you have to do means, let f of z equal to whatever you are taken numerator, this you assume as f of z. So f of z, let we are assuming e power z by z minus 1 whole cube. Okay, so now this you can write, this how you can write means integral c e power z by z minus 1 whole cube all divided by this z, you can write z minus 0. Okay, so what is Cauchy integral formula means Cauchy integral formula. What is that means? Integral c f of z by z minus a dz is equal to 2 pi I into f of a. Okay, so now this numerator, what is this f of z means e power z by z minus 1 whole cube. That is the reason I am assuming let f of z equal to e power z by z minus 1 whole cube. Next z minus a means z minus 0. So that means a value how much? 0. So therefore you find f of 0. You need your f of a, na? So find f of 0 e power 0 by 0 minus 1 whole cube. So that is 1 by minus 1 whole cube, that is minus 1. So you got f of 0. So by Cauchy's integral formula, Cauchy's integral formula, I am writing one more time. Integral c f of z by z minus a dz equal to 2 pi I into f of a. So what is the a value means here? 0. Okay, so therefore integral c, what is f of z? Just now you assume e power z by z minus 1 whole cube. E power z by z minus 1 whole cube whole divided by z minus a value means 0 into dz equal to 2 pi I into f of 0. So that is nothing but again it will come into denominator as it is e power z by z into z minus 1 whole cube dz equal to 2 pi I into f of 0. What is f of 0? Minus 1. This will be f of 0 minus 1. So therefore minus 2 pi I. Minus 2 pi I. So now you got answer by Cauchy integral formula. So here minus 2 pi I, previous method minus 2 pi I. So both answers are same. So in the key point is when you come to Cauchy's residue theorem, here first to find the poles, which pole is inside. For that pole you have to find the residue. So 0, 1 are two poles. 0 is inside. So therefore at 0 we are finding the pole. Is a pole of order 1. When pole of order 1, this is a formula. Okay. So now you applied z equal to a means a equal to 0, you got residue. After residue by Cauchy's residue theorem, 2 pi I into sum of residues. Only one pole is inside, its residue minus 1. 2 pi into minus 1 minus 2 pi. This is a Cauchy's residue theorem. Same problem here, Cauchy integral formula e power z by z minus 1 whole cube dz. So what are the poles? 0, 1. 0 is inside, 1 is outside. So here 1 is outside now. Which is outside? That factor take into numerator. We are taken. Okay. So that means this is a integral c e power z by z minus 1 whole cube into this z can be written as a z minus 0. What is Cauchy integral formula? Means integral C f of z by z minus a dz equal to 2 pi a into f of a. A means here 0. F of z means this numerator. So let f of z equal to this numerator e power z by z minus 1 whole cube. So a value 0. So f of 0 we are finding. You got minus 1. By Cauchy's integral formula, what is that? Integral C f of z by z minus a dz equal to 2 pi into f of a. What is a value means? A value is this 0. So f of z by f of z means e power z by z minus 1 whole cube, z minus a value 0 dz 2 pi into a value 0 f of 0. This as usual come into denominator. So 2 pi into f of 0. What is f of 0? Minus 1. So both ways you got answer.